Okay, final example over here. We want to find the points of intersection of the line x is equal to -1. So y x minus 1. So here I've got y is equal to -1. That's I'll call this my equation number 1. And the parabola y is equal to x squared plus 4x plus 1. And that's going to be my equation number 2. Okay, now, if I want to find a point of intersection, that's my second. I want to find the points of intersection. So what I'm going to do, just like I did in the previous question, is I'm going to solve these two simultaneously. What you notice is that y is all the way by itself on the side. So I'm going to substitute. I'm going to use the substitution method. Now I did it a different way in the previous one. I'm going to do it the way we've been doing it for the last while. So I'm going to sub 1 into 2. And so what I'm going to get is x minus 1 is equal to x squared plus 4x 1. I'm going to use the substitution method here. Okay, cool. I've got that. Now when we're solving here, what we've got here is this is a quadratic equation. The way I know this is because the highest power of x is the x squared. And so when I'm solving quadratic equations, what do? I'm going to move all of the terms onto one side. I'm going to move all of this to the other side so that I have all my terms on one side. I have the x squared as a positive. So here I'm going to move them all. So I've got 0 is equal to x squared. Now because I moved that x from the left hand side to the right hand side, it goes from plus x to minus x. So then when I subtract that from the 4x, I'm going to get plus 3x. That minus 1, when I move it to the other side, becomes plus 1. So plus 1 gives me plus 2. I'm just going to rearrange this. I'm going to move everything to the left-hand side because I like working with everything on the left-hand side. Now that I've done this, we've gone through a few different ways of solving this. The way that is easiest is by factorizing. So here I'm going to try and factorize my quadratic equation here. Quadratic expression here. So I've got x squared plus 3x plus 2. So I know that that's x plus 2, x plus 1 is equal to 0. And so therefore, when I'm trying to equate it with 0, I'm just going to solve for each of those linear factors. So I'm going to solve for x plus 2 is equal to 0 and x plus 1 is equal to 0. So here, when I solve for x plus 2, that gives me x is equal to minus 2. Or when I solve for x plus 1 is equal to 0, that gives me x is equal to minus 1. Now that I've done that, what do I need to do? Well, I need to sub them back into one of the equations. I'm going to sub x equal to minus 2 into equation number 1. And so when I do that, I get y is equal to minus 2 minus 1. Y is equal to minus 3. So therefore, my first solution is x equal to minus 2. Y is equal to minus 3. So that's my first solution. And then the second thing is I'm going to sub x is equal to minus 1 into the same equation. So I've got y is equal to minus 1 minus 1. So I've got y is equal to minus 2. And so therefore my second solution is x is equal to minus 1, y is equal to minus 2. Okay, cool. So I've got my two solutions here. Now, this question isn't asking me to find the solutions. It's actually asking me to find the point of intersection. What I need to do is then I need to translate these solutions to become my points of intersection. So I'm going to write underneath. So therefore, points of intersection are. Okay, I'm going to zoom in here. The first one was x equal to minus 2, y is equal to minus 3. So when I change that into a point of intersection, just remember points of intersection. Points are coordinates. Coordinates need two values. So I'm going to have bracket -2 minus 3. And the other one, which is the second set of solution, is x is equal to minus 1, y is equal to minus 2. And so here we go. This is my solution here. My points of intersection just correspond to the solutions I get when I'm solving my equations simultaneously. So this is how solving simultaneous equations actually links to what it actually looks like graphically is our points of intersection. When we solve our simultaneous equations and we get those solutions, they end up helping us find the points of intersection between the two graphs that you would have gotten if you graphed them on a Cartesian plane. Have a go at the questions for me. And if you need any help, feel free to ask or email me.